Okay, Einhell today, so I think it's the first time I've shown you these. These are the 12 volt varieties. Not sure if they even sell these anymore. I've been looking and kind of struggling. But one of you have sent a couple of these in. Got the same fault on both where they have no indicator lights on there and won't charge. So digging into it a little bit further, I've got about 3.2-ish on that one volts. And this one seems to be dead. Deader than dead. So we'll focus on the one that's got something in it today. I'll probably do another video on the other one if I get a chance. Very, very busy at the moment. A lot of you have been sending lots and lots of stuff in. So this one, say, first time I've shown you these, but they're just 4 screws on the bottom. Fairly simple to do, these ones. Most of these batteries are a couple of screws on the bottom, a couple on top, that sort of stuff. Couple. Right, so we'll get those off. It's just a normal bit you need for this, nothing special on here. Get those screws out and pop it open. So there's no safety pins or anything like that, nothing like the Makita ones where you've got to drill those little white bits out. Quite simple, just pop these open. And what we'll do is we'll figure out how we can test these 3 different cells. So they've got the points on the bottom here and the top on both sides. That's going to be how we're going to do the outer ones. The inner one's going to be slightly different. I'll show you how I do that as we get into it. But we'll be able to, in essence, work out what the 2 on the edge are, look at the overall voltage, and then just work out the difference. So it's not going to be too difficult. A little bit of maths there, but nothing spectacular. So we'll pop that out of the box, out the case, and just have a look around just like the others. There's no broken connections here, nothing, no dry joints, anything like that. So you can see on this one, hopefully if I can get it to read, 1.1-ish. And on the other side, I can touch the right bit, about 0.5 volt. So in theory, both of those are recoverable. The 0.5 volt one is a little bit more questionable, but certainly it is possible. I've done that before on voltages like that. And then if you take the whole voltage overall, take away those 2, you're left with what the middle one will be. So if you see both sides there, add those up, take them away from that, and that's kind of how you can work out what that one is. So not much of an issue there. They're all low, so we're going to have to bring them all up. So what I'm going to do, both of these sides, I'm going to bring up to sort of 3.5 to 4 if possible. Get those to 4, then I'm going to get the middle one up, and then what we'll do is go from there, see if I can get them recovered first of all. So there's a bit of time lapse on here. I'm not showing you the whole thing because this did take a number of hours, but in theory all I'm doing is bringing these 2 side ones up first, and then I'm going to bring that middle one up. So this is when the power's off. You can see it dropping. So they do drop for a while after you turn the power off as it settles on the voltage, and that's why you kind of have to charge over the number you want to get to and let it drop. So quite annoying sometimes, but that's just how these are. So we can see it's increasing, which is good. We'll go on the other side now. What I don't really want to do is just smash one side right up and leave the other 2 out. It's kind of I'm doing this in a gradual way, as safely as possible, really. I'll do the same on this side. And then what we're going to do in the middle is just pull back some of the insulation. And we're actually going to spot weld a couple of bits of nickel on the middle cell, and then do the same to that, basically. So a few different camera angles today. It's a different camera and a different tripod, if you like. So apologies, this is probably going to be a little bit annoying for some of you. I've got an arm thing coming tomorrow, which will go back over the top like it was on previous videos, but hopefully the quality will be much better. So hopefully it's worth it in the end. I've got to that stage where doing this on my phone isn't really sensible anymore. So I know you can't see that. This is really just to give you a little bit of a close-up on the battery and the different cells here. But we're getting there. We're almost balanced on those outer 2. There is a little bit of residue on this board as well, potentially water, but it might not be. But there's a little bit of let's call it stuff around those joints, but it's certainly not damaged, not dry joints or anything like that. So I'm hoping this is going to be successful. So we just keep going. So it's a slow process. I say it took me a few hours, but you just want to keep going. I've got it fairly low amps as well, and this is hooked up to a bench power supply basically. I know a few of you have asked before. I do try not to show you it on purpose because I don't want to be responsible for anybody blowing themselves up. So I'd rather this was entertainment than sort of a how-to sometimes. I'd hate to get a message from somebody's wife that they've blown the shed up with the husband in it. So hopefully you can see here what I'm trying to do. So I'm reading across the middle, and what I'm going to do to bring those up, I've got my little spot welder here. I'm going to pop these two little bits of nickel on either end and just do the same thing as I've done on the outside. And you can just charge up then through that bit of nickel, which is pretty simple to do. And these come off really easy because this spot welder isn't exactly the most powerful thing in the world. I can just pull these off. So all I'm going to do is sort of tack these two down both sides, and then we'll bring that up. I'll do the same on the other side, and then we'll get that one up so they're fairly balanced, and then we'll carry on. What we find here, this is about 11:30 at night, so I'll do this little bit and then I'll jump into the next day. And you'll notice because the coat's gone. But if I can grab this, I'll do the same here. Bring it up to voltage and then call it a day, and then I'll come back. So spot weld this side on. Quite fiddly this, and I'm trying not to break the other one at the same time, so it's quite awkward. There we go. So I've got one of those on both sides. So in a nutshell, I bring that up, and then I've got all of the cells at a very similar voltage. And then like magic, next day, slightly different angle. Slightly horrible jumper. And what I'll do is I'll just show you where we're at in terms of the cells, if you're interested. So these have settled about 3.6 there, similar there. And we'll just check that middle one just to show you after I've done that. Very similar. So we've got quite a balanced pack now, which is good. Now I've done that for a reason, and that's because I can now use the main connector to just bring this all up together. So what I'll do is I'll get my funky self-made bits of wire, and I'll pop these both in the proper slot. So in the positive side here, the other one in the negative. And then what we'll do is we'll use that bench power supply to bring the whole pack up together. So overall we're about 10.7 volts there, so we're not too far off. And again, this did take a long time, so please don't let the time this video takes fool you. It certainly is definitely around an hour, I think it was, on this second day to get this back up. And I go quite low on the amps because I don't want to just whack this up or cause any damage to it. So there's a lot of bits chopped out in terms of time here that this is on. I do keep coming back, check in, that sort of stuff. Check if the cells are overheating, all sorts of stuff. So there's a lot to these things. So I'll turn it off when I'm going to check here. And we're about 11.9 there, so we're almost at 12. I'm going to try and get to about 12. Then I'm going to leave this for another day or so, see if it manages to hold, and then see if I can do some load testing with something on this. See if we can get it right down maybe, and then right back up. Now I am struggling with the indicators on here as well, so when I do manage to get it up to 12, I still can't get that to work. So I'm hoping it's a bit like the Milwaukee's, where you put them on back on the charger and it sort of resets itself. So I'm hoping we've got a scenario like that. So here we've got just over 12. So that will be it, I think, for this day. I'm going to call that a success at this point. But what I'll do is I'll come back, I need to monitor if it's dropped, I need to try and charge this, I need to try and use it on something, just do some basic tests with it before I send it back. But it's been successful so far. That was overnight and they didn't really drop at all, those cells. So I'm hoping now a day, 2 days maybe, if they're around the same, I'd call that a success then at that point. Who knows how long this will last though. If that could happen again, it might do, especially the one that was at 0.5. But at least it gives it another shot at life. So get these back on. So the other one probably won't be as successful because it was basically at 0. But let's just see what's going on with that one. This one though, as I say, I'm going to call it a partial success for now. Come back. If we're good, I'll call it a big success. So whack the screws in. And I can get this to the side then. It is quite cold in the workshop as well, so certainly that could give it some other types of testing as well, environmental testing. See what happens tomorrow. That's how a lot of these things die in the first place. But that's it then, back together. So I'll pop back and hopefully that keeps its charge. But that should be good to go.